Students, this is 148th maths class. Look at that Boschman's textbook problems. Today I am going to explain left hand derivative and right hand derivative. So look at the definition, students. Left hand derivative, left side derivative and right side derivative. So how I defined? Look at this definition. L f c. L f c means left hand derivative of the function fx at the point x equals c. Left hand derivative L f c means left hand derivative of the function at the point x is equal to c, and is defined as, how this left hand derivative is defined. Look at that board, students. Limit h tends to 0 minus f of c plus h minus fc by h. So since it is left hand derivative, h value should be left neighborhood, left side number, h should be left side number of 0. All numbers which are on left side of 0 must be negative. That's what I written here. H is negative, that means h is negative. Less than 0 means negative. Similarly, we define right hand derivative in this way. Look at this right hand derivative, students. R f c, and is defined as limit h tends to 0 plus f of c plus h minus fc by h. Right hand derivative means h value should be right neighborhood of 0. H should be right side of 0. All numbers which are on right side of 0 must be positive. That is, h is positive. So these, remember by head these definitions, students. Let us solve problems on these definitions. Whatever I explain from this class onwards, so you practice them for your annual exam. Now I am explaining the textbook problems, students. So far I explained that in the previous class problems, you practice them. You practice previous class problems only for learning purpose. So let us solve problems on this, students. So right. First question, prove that fx equals mod x is continuous at x is equal to 0, but not differentiable at x is equal to 0. Look at the question, students. The function, modulus function, is continuous at x is equal to 0. X is equal to 0 means it is origin, but the same function is not differentiable at origin. That means mod x becomes continuous at the point x is equal to 0, but differentiating of this mod x, it is not possible at x is equal to 0. So already I explained. In that continuity chapter, you learnt that, students, modulus function is continuous everywhere. Let us repeat the same thing. To check the continuity, we have two conditions. One is limit x tends to c, fx is equal to fc, or one more is LHL is equal to RHL is equal to fc. We use this LHL, RHL, fc only if the given function contains less than and greater than symbol. Otherwise, we always use this condition to check the continuity. Let us go for that, students. It's so easy question. So C means 0. C means 0. Limit x tends to 0 fx. So that is limit x tends to 0. Fx means mod x. Mod x. Fx means mod x. Apply limit. That is mod 0. Mod 0. So we calculated. We found this value. Now let's find fc value. So fc. Fx is equal to f0. Put x is equal to 0, students. F0 is mod 0. That implies limit x tends to 0, fx is equal to f0. Look at this, students. This condition is getting satisfied. This condition is getting satisfied. What does it mean? It is continuous. Therefore, that implies fx is equal to mod x is continuous. So continuous at x is equal to 0. Now let us go for checking differentiability. Differentiability, whether it is possible to differentiate it or not. Let us check that condition. So right, differentiability. So see, left hand derivative. To say the given function as differentiable, left hand derivative should be equal to right hand derivative. If left hand derivative and right hand derivative are not equal, we say the given function as not continuous. Let us find left hand derivative first. Solution. So L f dash c. So limit h tends to 0 minus f of c plus h minus fc by h. In this case, c is 0. So tell me c value, students. C is 0. Put c is equal to 0. That implies L f dash is 0. So limit h tends to 0 minus f of 0 plus h. 0 plus h means h minus f of c is 0 by h. So you calculate fh value and f0 value. We have fx is equal to mod x. Fx is equal to mod x. Tell me, students, how much is fh? Put x is equal to h, you are going to get fh value. So fh is mod h. Next you find out f0 value. Put x is equal to 0. f0 mod 0, it is 0. Substituting that. So right, limit h tends to 0. Tell me fh value, students. Mod h minus f0 0 by h. Now you apply mod x definition. We have this definition, students. Mod x is x if x is positive. Mod x is x if x is positive. Mod x is minus x if x is negative. So this I explained in your continuing chapter. You apply these definitions for this. Right? L f dash 0. Limit h tends to 0. H tends to 0. Mod h. H is, since it is left hand derivative. In that left hand derivative, h is negative. Just before I explained. For that left hand derivative, h is negative. Since h is negative, according to modulus function definition, mod h should be minus h. You use this definition. So that is minus h. Need not to carry that 0. Carrying 0 not required. Minus h by h. H get cancels. Limit h tends to 0 minus 1. It is minus 1. Similarly, you calculate right hand derivative. So write rf dash 0 limit h tends to 0 plus f of 0 plus h. 0 plus h means fh minus f0 by h. Limit h tends to 0. fh, how much is fh, students? Mod h. f0 0. So by h limit h tends to 0. Since it is right hand derivative, for that right hand derivative, so h value right side of 0. All numbers which are on right side of 0 must be positive. Right neighborhood of 0, right neighborhoods of 0 must be positive. That is mod h. H is positive. If h is positive, mod h becomes h. Mod h is h by h. So that is limit h tends to 0, 1. It is 1. From this discussion, it is so clear students, left hand derivative is not becoming right hand derivative. Left hand derivative and right hand derivative are different, so therefore it is not differentiable. So that implies LF dash 1 is not equal to, LF dash 0 is not equal to RF dash 0. So that implies Fx equals mod x is not differentiable. At x is equal to 0. From this discussion it is so clear students, modulus functions are continuous everywhere, but they are not so differentiable. Differentiable means at that origin it is not differentiable. So at x is equal to 0, mod x is not differentiable. Let us solve. So one more question of the same type. Let us solve one more question of the same type. Let us solve one more question of the same type. Prove that fx is equal to mod x is so not differentiable. Fx is equal to mod x minus 1 is not differentiable. Not differentiable at x is equal to 1. You apply same method students. You apply same method. So that is left hand LF dash C. C is equal to limit h tends to 0 minus f of c plus h minus fc by h. In this case c is 1. In this case the value of c is 1. Put c is equal to 1 students. Put c is equal to 1. That implies LF dash 1 is equal to limit h tends to 0 f of 1 plus h minus f1 by h. Now you calculate both these two quantities. We have fx is equal to mod x minus 1. We have fx is equal to mod x minus 1. How do you get f of 1 plus h students? How do you get f of 1 plus h? In this put x is equal to 1 plus h. X ಜಾಗದಲ್ಲಿ 1 plus h ಹಾಕಿ ಬರುತ್ತೆ. So write f of 1 plus h is equal to mod. What is x? 1 plus h minus 1. Get cancels. It is mod h. So write we found f of 1 plus h value. Similarly you find out f1 value. f1. So write f1. Put x is equal to 1. f1 mod 1 minus 1 mod 0. It is 0. You substitute both these two in that students. So LF dash 1. So LF dash 1 limit h tends to 0. So how much is f of 1 plus h value? How much is f of 1 plus h value? It is mod h. f1 value is 0. So by h. So write limit h tends to 0 mod h. Again by the same reason. This is left hand derivative. H is negative. According to modulus definition, mod h should be minus h. Minus h by h. So limit h tends to 0 minus 1. Apply limit. Limit cannot be applied. Minus 1. Similarly you find out RF dash c. So limit h tends to 0 plus f of c plus h minus fc by h. So write again c is 1. So you substitute 1 for that c. So limit h tends to 0 f of what is c? 1 plus h minus fc f1 by h. So write limit h tends to 0, f of 1 plus h. Tell me f of 1 plus h value, students. How much is f of 1 plus h? Mod h minus f1. Tell me f1 value, students. 0 by h. Again, this is right hand derivative. For that right hand derivative, h value positive. Since h is positive, according to modulus function definition, mod h becomes plus h. You use modulus definition, mod h is h. R f dash c, R f dash 1, R f dash 1. So wait, R f dash c. This is R f dash 1 is equal to limit h tends to 0 plus f of 1 plus h. Replace c by 1. Replace c by 1 minus f1. So by h. f1 by h. So you substitute for f of 1 plus h. R f dash 1 is equal to limit. So limit h tends to 0. So substitute for f of 1 plus h. F of 1 plus h is mod h minus f1. f1 value 0. That is 0 by h. Since it is right hand derivative, students, this is right hand derivative. So write mod h. Right hand derivative means h is positive. If h becomes positive, mod h becomes h. Limit h tends to 0, h by h. So write limit h tends to 0, 1. It is 1. From this it is so clear. L f dash 1 is not equal to R f dash 1. So write from this it is so clear. That implies L f dash 1 is not equal to R f dash 1. So left hand derivative and right hand derivatives are not becoming equal. What does it mean? The function is not differentiable. This implies fx is equal to mod x minus 1 is not differentiable. Not differentiable at x is equal to 1. So the function is not differentiable at x is equal to 1. I hope you understood, students. Now I am going to write some useful points. Remember the following. So remember the following. So first point, continuous implies can be either differentiable or not differentiable. Second point, so not continuous implies not differentiable. Third one, differentiable implies continuous. Look at these points, students. Useful points. These points are useful for your future. If a function is continuous, that continuous function can be either differentiable or not differentiable. Continuous functions can become differentiable functions or not differentiable. Continuous means just before I explained that using example mod x is continuous but it is not differentiable. Continuity, if a function is continuous then the differentiating of that function can be either possible or cannot be possible. Come to this one more point, not continuous. If a function does not become continuous, if a function is not becoming continuous, surely it is not differentiable. Surely it is not differentiable. Come to third point, if a function is differentiable, surely it is continuous. Differentiability implies continuous. If a function, if it is possible to differentiate the given function, surely it becomes continuous. I hope you understood, students. Let us go for solving some simple questions. Let us solve some simple questions. So right. Let us solve. Let us solve some simple questions. Find the derivative. Find the derivative of the following functions. Find the derivative of the following functions. You practice these questions for your annual exam, students. Surely they are going to ask questions on this. So simple questions. Now let's go for. So now let's have a discussion about that. First one, fx is equal to sin x square. Fx is equal to sin x square. So right, look at this simple question. So it's 2 mark question. It is 2 mark question. So you apply power base angle. Power. We don't have power. The power is 1. Power is 1. Base is sine. Angle is x square. Carefully observe. This power 2. This power 2. It is the power only for x. It is not a whole power. It is not a whole power. You should not start differentiating from this. You must start differentiating from whole power. This is whole power. Sine square theta. Look at the students. Sine power n theta is same as sine theta 4 power n. So, but sine theta power n is not equal to sine power n theta. This is not correct. Carefully observe. Since we have the power as 1, power is 1. Since power is 1, need not to differentiate that power 1. If the powers are more than 1, you should differentiate that by using x power n formula. Power 1 ಇರೋದನ್ನ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಪವರ್ 1 ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಮಾಡಬೇಕು. You come to base. Differentiation of fx is f dash x. You write, you use f dash x or dy by dx or y1 or y dash. Now differentiate sine. Differentiation of sine is cos. Writing only cos is meaningless. You had angle also, that is x square. So into differentiation of sine x square is cos x square. Differentiation of sine is over. You buy the tool. While differentiating power, keep the base as it is. While differentiating base, keep the angle as it is. Now differentiation of base over. Now go inside. Differentiation of x square is 2x. Write that neatly once. F dash x is 2x into cos x square. That's all. So let us solve one more question, students. Let us solve one more question. Fx is equal to so tan 2x plus 3. Fx is equal to tan 2x plus 3. Okay. So differentiation. Here again we don't have power. Base, we have base angle. ಟ್ಯಾನ್ ಮೊದಲು ಟ್ಯಾನ್ ಮಾಡಿ ಆಚೆಯಿಂದ ಒಳಗಡೆಗೆ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ ಯು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಫ್ರಮ್ ಔಟ್ಸೈಡ್ ಅಂಡ್ ಕೀಪ್ ಗೆಟಿಂಗ್ ಇನ್ಸೈಡ್ ಸ್ಟಾರ್ಟ್ ಡಿಫ್ರೆನ್ಷಿಯೇಟಿಂಗ್ ಫ್ರಮ್ ಔಟ್ಸೈಡ್ start differentiating from outside, keep getting inside. That is called as chain rule or differentiation of composite functions. So differentiation of fx is f dash x. So first differentiate tan. Differentiation of tan is secant square. Keep the angle as it is 2x plus 3. After differentiating tan, get inside. Differentiate 2x plus 3. Differentiate 2x then 3. That is, come to this constant into function, differentiation of 2, constant into function, keep the constant as it is. Differentiation of x is 1 plus differentiation of 3 is 0. 2 into 1 it is 2, 2 plus 0 that is 2, 2 into f dash x is 2 into secant square 2x plus 3. Now let us go for one more question, students. fx is equal to so next question, sine of cos x square, so this function is not named, so naming is not done. Usually we name the given functions either by fx or y. You take that given function as either y or fx. I take that as y. You hengaadu tagolbodu. Let y equals sine of cos x square. Again we don't have power. Sin theta, idistu theta agutte. Sin theta, sin power 1. We have whole power as 1. Sin theta, sin ಏನು power ಇರುತ್ತೋ ಅದು whole power ಆಗುತ್ತೆ. Power is 1 need not to differentiate. First differentiate sin, go inside. Next differentiate cos, next go inside. ಮೊದಲು sin ಮಾಡಿ ಆಮೇಲೆ ಒಳಗಡೆ ಹೋಗಿ, ಇನ್ನೂ ಒಳಗಡೆ ಇದೆ ಒಳಗಡೆ ಹೋಗಿ. Differentiation of base, first differentiate base, go for the angle. Still we have one more angle. You differentiate that angle also. Last ವರೆಗೂ ಹೋಗಬೇಕು. Keep that in mind. So dy by dx. So differentiation of sin is cos. Sin ಮಾಡಿದ್ರೆ cos, ಉಳಿದೆಲ್ಲ ಹಾಗೆ ಇಡಿ. Cos of x square into differentiation of cos is minus sin. Cos ನ ಮಾಡಿದ್ರೆ minus sin. x square ಹಾಗೆ ಇಡಿ. Next differentiation of x square is 2x. ಎಲ್ಲಾನು ಡಿಫರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದೀವಿ. ದಿಸ್ ಇಸ್ ಕಂಬೈನ್ಡ್ ಫಂಕ್ಷನ್. ಹೌ ಮೆನಿ ಫಂಕ್ಷನ್ಸ್ ಆರ್ ಕಂಬೈನ್ಡ್ ಇನ್ ದಿಸ್? sin cos x square. ಇದರಲ್ಲಿ sin ಇದೆ, cos ಇದೆ, x square ಇದೆ, ಮೂರನ್ನು ಮಾಡಿದೀವಿ ನೋಡಿ. ಬಟ್ ಮೀನಿಂಗ್ಫುಲ್ ಟರ್ಮ್ಸ್ ಬರೀರಿ. ರೈಟ್ ದಟ್ ಆನ್ಸರ್ ನೀಟ್ಲಿ ಒನ್ಸ್. ಸೊ dy by dx is equal to minus 2x into sin x square into cos x square. So right. So a into b into c is same as b into c into a. I hope you understood, students. Let us stop this class. We shall continue in the next class. Thank you.